Application of Nuclear and Radioactive Physics with Michael Heaslip and Jack Levis.
How is the knowledge of radioactivity applied for practical use in checkups for aircrafts and shipses?
No S, it's already plural. You wouldn't say Chinese's.
For regular checkups of ships and aircraft in Australia, the process of radiography is used. These checks are required to make sure the parts of a plane vital for staying airborne are completely intact and acceptable, and checking the seaworthiness in boats.
Radiation is a major part of life nowadays, with it being involved in many fields including agriculture, environmental science, manufacturing, mining, power production, and medicine. One way to use radiation is radiography, and this process is now being used for the maintenance of large ships and aircraft. It is used in order to detect even the smallest imperfections and faults in the numerous different parts of large vehicles, very much like an X-ray we use in medicine. This is able to speed up maintenance processes and increase checking efficiency, and eliminate much of the possibility for human error.
The source of radiation is held within a casing and emitted through a tube to go over the object that is being studied, as shown here. The source of the radiation is placed in a position so that the radiation will pass through the object that is being studied. Then the radiation comes through the object and is passed onto a film. This will show results.
Directed toward the item on the chest, in this case, a weld. A certain amount of radiation will be absorbed by the material.
When an object has an internal flaw, the radiation will reach the film in these areas with a different concentration level. The film will show a different shade or shape in the area with a different radiation amounts reach the film. Here is a crack on a welding joint that is clear evidence on the film, a change in shape and shade in the damaged area.
The radiation that is used most commonly is short X-rays and gamma rays, which both have a high penetrative power and therefore can pass through most metals of varying thicknesses. Iridium-192, Cobalt-60 and Caesium-137 are all the most common, with all of them possessing useful properties and emitting the correct types of radiation with the correct frequencies and wavelengths when it comes to industrial radiography.
What areas in an aircraft most commonly fail, and what areas are most commonly checked? An analysis of 122 maintenance errors detected by major airlines over a 3-year period revealed the following breakdown. 56% of errors were due to emissions. When breaking down this 56% of emissions, the results were: fasteners left undone or incomplete resulted in 22%. Items left locked or pins not removed, 13%. Filters or breather caps loose or missing, 11%. Items left loose or disconnected, 10%. Spacers and washers put on wrong, missing, 10%. Tools and spare fasteners not removed, 10%. This perfectly correlates with the abilities of using radiology to detect these problems, as radiation particles will show obscurities on the film that reflect the problems at hand. Jack,
Yeah.
what areas on an aircraft are checked most frequently by radiography?
The areas that are most commonly checked by industrial radiography are flight surfaces, landing gears, windows and windshields, fuselage, engines, welds and high-pressure piping, and also non-metal components such as ceramics, which are all regularly tested.
Jack,
Yeah, Mike?
would you be able to tell me, is this form of radiography performed on site?
I sure can, pal. I can tell you that radiography can be performed on site. Boundaries can be set up around the site, and the source of radiation that is used can be contained in thick lead boxes. This is so the operator is not exposed to the radiation and doesn't get radiation poisoning or burns. However, the films and pictures of the parts are not necessarily read and assessed on site, as they require some knowledge and experience in order to tell if there is a fault or flaw in a part, and if it requires immediate repair or can be attended to at a later date.
Also, Jack, to add to that point, the technician who is using the radioactive equipment can stand a safe distance by using this activation tube and then putting himself behind a door which will stop radiation.
Action.
100 straight, Mr. Obama. No. Thank you, Mr. President. Oh, hey guys. Do you want me to teach you about when industrial radiography was first introduced? Well, technically, radiography started in 1895 when X-rays were discovered, but they were first introduced industrially soon after World War II when they were used on military equipment.